Okay, so now let's carry on, and instead of a torus, we're going to create a flat plane that's going to represent the flat surface a lot better. Now, in order to do this, we are going to be, so let's make a bit more space, and you can see how this anchor here is not a plane anchor. We can cast this as a plane anchor because we have some plane detection, and when ARKit recognizes a plane, it will add this anchor. So what we need to do first is to cast this anchor, this AR anchor, as an AR plane anchor. And from that, we will be able to get the size of the plane that we just detected. Okay, so let's just have a look at how this would work in code. So I'm going to comment this out. And here I am, keeping this anchor node so that we understand what's going on. Right, so first we need to create this plane anchor. So let plane anchor equals, so this is our anchor once again here, but we are going to try and cast this as an AR plane anchor. And if for any reason this doesn't succeed, we'll just return, so else return. Okay, and here we need a guard, so the guard else makes sure that basically this will return and nothing after this will get executed if this plane anchor can't be created. Now, if it does get created, that's going to be very good for us because we can then get the size of it. So let size equals, so we can call it plane anchor, and here we can see what it's got inside of it. And you can see that we have this third one, which is called extent. So the estimated width and length of the detected plane. That's exactly what we want. Now, funnily enough, this is a float 3, which means that if I go and inspect that, you will see that a vector float 3 returns something that looks like this. Now, we were just told that we would get width and length, but we got 3 parameters there. So basically what we get is x, y, and z. And the y of a plane is always 0. So we don't actually care about this middle one here. Right, so instead of size, I'm going to call this extent because we now know how this is called. So the extent is going to give us an x and a y. So now let's create a plane. So let plane equals, so this is going to be our geometry. So SCN plane, and here we can pass a width and a height. So the width is the extent dot x, and the height is the extent dot z. Right, and this will return an error because this extent dot x, remember it comes from a float 3, which means this x here is a float. However, to make a plane, the width needs a CG float. So if you just fix it directly with Xcode, you will see that now it's casted as a CG float. And that's all we need to do, but twice, obviously, because we have X and Z. Okay, so our plane geometry has been created, so we can add now, let plane node, let's put a capital N here, equals, so that's going to be an SCN node, and I'm going to pass the geometry that we just created, the plane. So now we just need to add this plane. here to our node. However, we'll have a little problem. So if you go back to the ship here, and let's just add some procedural sky to understand a bit better. Okay. And in here, so we don't want to, yeah, let's just have a torus. And the torus was horizontal when we add it. That was fine, that works, no problem. However, if I use a plane, you will see that a plane is vertical. By default, planes will come as vertical. So what we need to do is to orient it like this. And if you check here, that means a minus 90 degrees, basically. So minus 90 in the X Euler. So this is what we need to do, otherwise our planes will appear vertical. So if I go back in here, I can call the plane node and look into the Euler angles. And remember, it's the X that we need to change, and that would be a minus 90. So you could do a degrees to radians, but I don't have this extension installed in this very app. However, I'm not going to use this extension in this app because I only need to use this once, really. So let's just make this with radians, right? So you may know that pi 314, etc., is 180 degrees. So if we divide this by 2 and just add a dot in front, so dot pi divided by 2, and obviously this is a minus, so now we've got minus 90. Okay, let's run this. Oh, before, sorry, I forgot. So we need to add this plane node, obviously, to this node there. So node dot add child node, and that's going to be our plane node. And now this should work. So let's just run. Okay, so the app is launched. Oh yeah, I forgot. We have we have a big torus in our scene. So if I now look around, okay, yeah, this just added a plane on the ground as well. And if I look in here, there we go. We have the clock with the plane on top and our anchor. So I need to remove the torus and this plane because it looks very messy, obviously. But we're making good progress. So now what we want to do is to update those planes when the anchors get updated. And ARKit does this for us. We just need to make sure that we update the plane every time ARKit updates the anchors.